All right, this is our third and final part on trig identities from 10.1. And what we're going to do, we're going to add one step to what we've been doing so far. So basically in part one, we reviewed our identities and took a look at how to use them. In part two, we focused on simplifying expressions. We're going to add one thing to that. So what we're going to do is we're going to add kind of a basic math step to it, where we're going to do things like factoring, or multiplying, or adding and subtracting. And then we're going to combine that into our simplifying problem. So let's start with factoring. And a lot of times when you're simplifying, it can really help you to factor first. So there's a couple types of factoring. I'm going to start with the easiest one, the easiest to recognize, and that's common terms. So if you're looking at your expression that you're trying to simplify, and you notice that you have the same trig function in there more than once in every part, you can factor it out. So let's look at an example where you do that. All right, so what we're going to do for this example is we're going to factor and simplify sine x minus cosine squared x times sine x. And right off the bat, here is your like term. That's what I was saying. So we have a sine x in both parts of this problem. Let's factor it out. So if you factor out that sine x, what it leaves you with, when you divide sine x by sine x, it leaves 1. And when you factor it out of the second part, it just leaves cosine squared x. So that's the first step. That's the factoring part. Now comes the simplifying part. So we want to think of our identities just like we did in part 2. Now, as soon as I see that cosine squared x, I think of Pythagorean identities. And in fact, 1 minus cosine squared x is sine squared x. So let's make that substitution. Now what we actually have is sine x times sine squared x, which gives us sine cubed x for our final answer. Okay, so that was an example of factoring out common terms, but as we know, there's another type of factoring. So I want you guys to think of that factoring where you're factoring a quadratic, like x squared plus 5x minus 6 or something like that. We can do that with trig functions too. So what you want to do is you want to notice when you have more than one of the same trig function, but with exponents, like maybe you have a sine x and also a sine squared x, or a tangent x and also a tangent squared x, something like that. Or something like this example right here. So we are going to factor cosine squared x minus 3 cosine x plus 2. And what you notice, this is what I was mentioning earlier, you have a cosine squared x here, and you have a cosine x here. So let's imagine that this problem was exactly the same, but instead of cosine x and cosine squared x, it was just x and x squared. So if this question just said x squared minus 3x plus 2, this is a very easy factoring problem. This is the one where we're looking for numbers that multiply together to positive 2 and add up together to negative 3. That would be negative 2 and negative 1. So what we have here is, instead of having x squared and x, we have the exact same problem, but with cosine squared x and cosine x. So when we go to answer this question, when we go to factor, we can factor just like our other one, but instead of having x in front of each factor, we're going to have cosine x. But after that, the rest of the question is the same. So we're still looking for two numbers that multiply together to be positive 2 and add to be negative 3. It's negative 2 and negative 1. And that's our answer. We factor. All right, so that was the two different types of factoring when you include trig functions in the problem. Now, the last thing I want to talk to you guys about today is if you include an operation, a math operation, like adding, subtracting, or multiplying before you simplify. Now, we know how to do those things, so what you want to do is just make sure you remember things like, number 1, order of operations. You always want to take care of parentheses first, exponents second, multiplication, division third, adding and subtracting last. You might also need to FOIL. If it's a multiplication problem and you have two binomial expressions in parentheses, you might need to FOIL it out. Or if it's an adding or subtracting problem that includes fractions, then you need common denominator. So let's look at an example of actually that third one. We're going to do an addition problem with fractions, so we need a common denominator. So we're going to, the directions say add and simplify. We're going to do the adding part first, and then we'll simplify. So when I look at this, I think, okay, my first denominator is 1 plus cosine theta, and my second denominator is sine theta. So to have a common denominator, it needs both of those things. So basically, this first fraction, I'm going to multiply top and bottom by sine theta. And this second fraction, I'm going to multiply top and bottom by 1 minus cosine theta. And that way, both fractions will have a common denominator. In fact, let's go ahead and put that common denominator in. Both fractions' denominator will be sine theta times 1 plus cosine theta. Now on top of the first fraction, we have sine theta times sine theta, which would give me sine squared theta. Now for the second one, what I'm going to do is I'm actually going to distribute this cosine theta here. So I will have plus cosine theta times 1 is cosine theta, plus cosine theta times cosine theta is cosine squared theta. So that was the adding part. That's finding a common denominator and adding. Now comes the simplifying part. Now one thing I want to point out here, even though it's not maybe written in the right order, this together is your main Pythagorean identity, sine squared theta plus cosine squared theta. That equals 1. So let's make that substitution. Let's make this 1. We'll still have that plus cosine theta from the middle. And on the bottom, we'll leave it for now. Now what you notice is what was left over on top, 1 plus cosine theta, cancels with what was on the bottom. And what we have right now is 1 over sine theta, which, using our reciprocal identities, would end up just being cosecant theta. And that's my answer there. So the first step was finding a common denominator and adding. The second part of that question was what we talked about in part 2. It's using your identities to simplify as much as possible. All right, that was part 3 and the end of section 10.1.